Hi, this is Mr. T. Crane talking about linear programming, and this is part one of a several-part video on linear programming. And today on this video we're going to be talking about identifying the feasible region. And when we talk about feasible region, we're just talking about the part of the graph where all of the points in that region make all of the inequalities true. So for example, I'll look at number 2 from the classwork on October 28th. I gave you a problem that had 4 inequalities, that's these guys here, and an objective function. And what I want to do is first just make sure that we can find the spot on the graph that makes all of those inequalities true. So let's talk about that a little bit. Let's start with the first one. X is bigger than or equal to 0. That means I want to find all the points on the graph where the x-coordinate is bigger than or equal to 0. For example, this point out here is at 10 on the x-axis, 2 on the y-axis. So this is 10, 2. The x-coordinate 10 is indeed bigger than 0, so that point is in the feasible region for that particular inequality anyway. If I look at another point, say this one right here, that's at x equals 2, y equals 6, so that's at 2, 6. That also satisfies the inequality x is bigger than or equal to 0, since the x-coordinate is indeed bigger than 0. So there's a lot of points where x is bigger than 0. There are a lot where x is not. For example, on this side of the axis down here, this is -2 on the x-axis, 3 on the y. That's -2, 3 is the coordinate. But the x-coordinate there is not bigger than 0. So that point does not satisfy the inequality. So I'm only interested where the x-coordinates are positive, and the x-coordinates are positive over here on this side of the x-axis. And it doesn't matter what y is, so I can shade all the way up here and all the way down here, and indeed anything on the right side of the y-axis. The y-axis is where x equals 0, so I want everything over here. So all of these points satisfy that first inequality. Everything to the right of the y-axis has coordinate where the x-coordinate is bigger than 0. So that's that first inequality. Let's look at the second one. Y is bigger than or equal to 5. Now, I want to graph all the coordinates where the y-coordinate is bigger than or equal to 5. So up here, the y-coordinate is 10, so that's okay. Or for example, another point over here, and for some reason that's not graphing, so there it is. So 6, 11, because I got to go 6 on the x and 11 up on the y. So 6, 11, the y-coordinate is indeed bigger than or equal to 5, so that's okay. If I pick a point right here, that's at 10, 2, because I got to go over 10 and up 2 from the origin. So that y-coordinate is 2, that's not okay. So where do I find everything bigger than or equal to 5? Well, this line that we drew here, straight across, that's y equals 5, and if I want y to be bigger than 5, I got to shade everything above that. Here's the thing. I need points that satisfy both x is bigger than 0 and y is bigger than or equal to 5. So I want to keep things to the right of the y-axis and above that line y equals 5. So let me get rid of these coordinates for a minute. I want to shade everything above this line, but to the right of the y-axis. So I'm going to shade everything in this region. So I've kind of knocked off a good chunk of my graph, but I still have quite a bit to look at yet. So now let's look at x plus y is less than or equal to 15. The boundary on that, here's the thing, x plus y, when I add the coordinates, I could get exactly 15, I could get a number bigger than 15, I could get a number less than 15. So the boundary line is x plus y is equal to 15. So if I were to graph this line, if I let x equal 0, then I would get 0 plus y is 15, so y must be 15. Or if y is 0, then x must be 15. So I'm looking at the line that contains those 2 points right there. That's the line x plus y equals 15. And now, where am I interested? Which side of that line do I want to graph? Because that line divides it into three sections. X plus y equals 15, and on one side x plus y is going to be bigger, and on the other side x plus y is going to be less than 15. Now I got to figure out which side that is. The easiest ways to do this is to pick points. If I pick a point above the line, when I say above I mean take any point on the line and go up from there. So this point, for example, is at, where is that, 3, because I got to go over 3 and up 15. So 3 comma 15, if I add them, 3 plus 15, I'm going to get 18. That's bigger than 15, so that one's no good. If I look below the line, somewhere below the line, pick any point in the line and go down a little bit. The coordinates at this point are 6, because I got to go over 6 from the origin, and up 6 comma 6. If I add them up, because it says x plus y, I got to add the coordinates. 6 plus 6 is 12. 12 is less than 15. I want it to be less than 15, so that's okay. So what does that mean? That means I need points that are below or on that line. Let me get rid of the coordinates. So again, we were looking for stuff to the right of the y-axis and above the line y equals 5. That satisfies the first two inequalities. And for this one, I want stuff below this line that's still in the region. So I'm looking at this section here. Please note there are other things, other points that I could shade that are below this line. But they've got to be in the spot where x is bigger than 0 and y is bigger than 5. I'm going to get rid of these other things because they're no longer in that region. So right now it's just the green space that I want. This one, I didn't mean to erase that. It's this stuff right in here that I'm interested in. The last inequality I've got to look at is this one. 2x minus y is less than or equal to 3. Again, I'm going to look at the boundary of 2x minus y is equal to negative 3. And if I were to solve this for y, let's see, I could subtract 2x from both sides. I get negative y equals negative 2x minus 3. I want positive y, so I'm going to make that a y equals. If I change the sign there, I got to change all the signs. 2x plus 3. And that is this line. It's got a slope of 2, over 1 up 2, over 1 up 2, over 1 up 2, and I've got a y-intercept of 0, comma 3. So that's the line. But again, since I want the inequality, I have to decide where are the points that are less than or that satisfy this inequality, making 2x minus y less than negative 3. The line is where they're equal to negative 3. Where are they less than negative 3? So again, I'm going to pick some points. Let's see. I'm only interested in this green spot, one side or the other. So let me pick a point on either side. Let's try this one. That point has coordinates, let's see, over 5 and up 7. So 5 comma 7. Again, I'm trying to satisfy this. 2x minus y is less than or equal to negative 3. If I plug in 5 for x, I get 2 times 5 minus 7 is less than or equal to negative 3. So that would be 10 minus 7 is less than or equal to negative 3. So 3 is less than or equal to negative 3. And that's false. Right? 3 is actually bigger than negative 3. So that point is no good. I don't want that point. So I don't want the region over here. Let's try a point here, somewhere on this side, in the green again. I want to stay in the green, in the spot I already know that is important. The coordinates on this point are 1, comma 11. And if I try that one, again, I'm satisfying the inequality. 2x minus y is less than or equal to negative 3. That's what I'm working on. I plug in the 1 for x and the 11 for y, and I want to see if that's true. I get 2 minus 11 is less than or equal to negative 3. 2 take away 11 is negative 9. That's indeed true. So it is the stuff on this side of the line that I want. So that's what I'm going to shade. It's this section that becomes important. all the points in this part make all of the inequalities true. And any point I pick is going to work. If I pick a point anywhere else on this graph, I'll make some of the inequalities true, but not all of them. And that's what I mean by feasible region. In part 2 of the video, I'm going to talk about what to do with the objective function. Thanks very much. Bye.